Okay, so this is integration by parts. So just to recap what we did last unit, because we're kind of continuing on with like lots more methods of integration. So you have just regular integration where you can just look at it and see what the answer is. You end up with a lot of things like 1/3 x cubed and 1/4 x to the 4th and 1/5 x to the 5th and so on. Like you can kind of just look at it and go, oh, that's the answer. If not, you can do a U substitution. That allows you to do a chain rule in reverse. You would let U equal like the guts of the problem. Then we had those inverse trig, like the arc trig patterns. And sometimes you had to complete the square to make it look like that pattern. And then we had the synthetic division. So this is going to be like another tool in your toolbox. And just by way of foreshadowing, we're going to do more methods of integration this unit. Like there is more coming. Okay. So what integration by parts allows you to do backwards is a product rule. So let's look at the product rule real quick. Because we're going to do that in reverse is what we're going to do now. So we're going to put d dx, and this is just basically a lot of weird notation just to go through this. It's a derivative, and I'm going to do u times v because that's usually how you see it written out. Just make sure your u's are real curly and your v's are real pointy so you can tell the difference between them. But what is your product rule? It's the first thing times derivative of the second plus second. Perfect. Okay, so that would be u times v prime plus v times u prime. So if u prime and v prime are continuous, let me make that v really pointy. I just said we need to be able to tell the difference. So if u prime and v prime, those derivatives are continuous, then, and what we're going to do is integrate both sides of this. So if you integrate this side, an integral and a derivative undo each other, right? Like they're going to cancel out. So you would just get u times v. So u times v equals. Now the v prime and the u prime, that's going to be the dv or the du. So this is going to be integral u dv plus integral v du. It's like we're mixing and matching them there. And what we want to do is get this part, this integral u dv by itself. That's the part we want to solve for. So I'm going to subtract this to the other side. Are you guys all following me there? Because I'm just going to, like, this is algebra. I'm just going to move this over. So we're going to get integral u dv equals u times v minus integral v du. That is the thing that you want to like highlight or underline or put stars next to. That's kind of like the formula that you have to memorize. Here's the pep talk. I know that it looks like the alphabet just threw up on your paper. Just like with the u substitution, if you don't let the u and the dv equal the correct thing, it simply won't work out. And you'll go, oh, I should switch that around. So if you have a little bit of perseverance, like you'll get it. Like I had one person say to me one year, oh, so if I just don't give up and keep on trying different things, I'll eventually get it. Yeah, you will. Okay. The other thing I want to say before we try a problem is dv must include the dx from the original problem. So whatever you let dv equal, that has to include the dx from the original problem. This is very process driven. It is very cut and dry. Here, do these problems kind of boring. Again, some people sort of like that, like, oh, once I get the hang of it, you can just, do a bunch of problems. But it is a drill and practice thing. So you're going to do a little bit of writing. I can't just do one or two of these. Like you're going to have to practice a bunch. So you're probably like, how do I know when I need to use this? It's when you see in the integrand two items multiplied together, like two functions being multiplied, because what it is for a product rule. Also, if you try everything else and nothing else works, then like this is what you want to go to. If you try to do just a regular u substitution here, nothing's going to work out. Okay. So what we want to figure out is what we're going to let u equal and what we're going to let dv equal. So in general, you want to let u equal the x or the 2x or the x squared or whatever that is in the problem. And you want to let dv be something that's going to kind of cycle. Like, you know how e to the x is its own derivative and its own antiderivative, or like how sine and cosine bounce back and forth from each other. You, in general, want to let dv equal that part. So dv is going to be the e to the x dx. But again, if you mix them up, it's just simply not going to work. And you'll be like, oh, let me flip that around. Now, here's where this is a little tricky. From u, you need to do a derivative to get du. And from dv, you need to do an antiderivative to get v. So on this one, you're going to do a derivative. And on this one, you're going to do an antiderivative. That's really hard. So if you struggle with that, give yourself a little bit of a break. You have to really switch gears in your head. This one's a derivative. This one's an antiderivative. All right, so derivative of x. So what is that going to be? There's just one dx. Good. Okay, that's the derivative. That's basically like a u substitution. Here we have to do the antiderivative. Now I made the first problem, I'm going to start with an easy one, right? So antiderivative of e to the x is just e to the x. And you can always check it, like the derivative of this should be this. All right, so here's our formula. It's going to be u times v. So we're going to multiply these two together. So it'll be x times e to the x. No, because sometimes there will be an x squared or an x cubed or an e to the 7x. Like, we'll do more examples. I tried to make the first one as easy as possible. No, it will not always be just this. Or wait, no, it won't be, because you have to do an antiderivative here. Okay, so u times v minus integral v du. So that's these two things. So v du, that would be e to the x dx. And then your last step is to do that antiderivative. So you end up doing two antiderivatives because you do one here, and then once you set up this problem, you do another one. So there's two antiderivatives there. But again, I made the first problem simple. Antiderivative of e to the x is e to the x, and then we'll put the plus c at the end. So this is the answer. But you can do this if you want, if you don't trust me and you want to check. If you do the derivative of this, you will get this. We just did it backwards. All right, let's try another one. All right, so we are going to let u equal x. And so du would just be dx. And sometimes I'll do that, like I'll just go ahead and do that derivative. Because doing a derivative on one side and an antiderivative on the other it's really hard to switch gears. So dv is going to be the cosine of 2x dx. Now you have to do an antiderivative to get v. It'll just be sine, but because there's a 2x in there, it is going to be 1/2 sine of 2x. If you do, pretend you don't have the 1/2 there. If you do the derivative of sine of 2x, you would get cosine of 2x times 2 for the chain rule. So you need the 1/2 there to cancel it out. All right, so your answer is going to be u times v. So we're multiplying these together. So I'm going to put the 1/2 out front. It would be 1/2 x sine of 2x. So u times v minus, and again, this is the little formula I'm following, minus integral v du. So we're going to multiply these together. So it would be 1/2 sine of 2x dx. And then you have to do that antiderivative. Like I said, there's two antiderivatives. So now we've got to do this antiderivative. So this first part's going to just like be there. So I need an antiderivative for sine. What do you guys think? It's negative cosine. So these negatives are going to cancel. It'll be plus. Now, cosine of 2x, but I would need to multiply that by a half. Now, out front, there's already a half. So that's going to make it 1/4, and then plus c. You can always check your work by doing a derivative. If you do the derivative of this, you will get negative a half sine 2x. Right, when you do the chain rule and you multiply by a 2, 2/4 would reduce to 1/2. I'm changing the order I wanted to do these in, like not following my paper exactly here. All right, so we're going to let u equal 3x. And so like I said, sometimes I'll just go ahead and do that derivative right away. That derivative would be 3 dx. And so dv is going to be the e to the 5x dx. Good, 1/5 e to the 5x. Good. You need to see a few of them to get the hang of it. And that's why your question threw me for a loop, or you're like, is it always going to be these two things multiplied? And I was kind of like, well, like sort of, but sometimes there's like an adjustment in there. So you asked me a question I had to think about for a second. I was like, all right, so it's going to be u times v. So that'll be 3/5 x e to the 5x minus integral v du, which would be 3/5 e to the 5x dx. So that first part is just going to be there. You're basically just going to copy that down. Just don't do a copy error, because I know there's a ton here. And then you just have to do this antiderivative. Now, because of that 5x in there, you're going to have to multiply by a 1/5 again. You're doing it twice. It's going to happen twice. So instead of 3/5, it'll be 3/25. Good. E to the 5x plus c. We'll do one more and then we'll do a break. And again, you can always check your work by doing a derivative. If you do a derivative of this, you will get what the original problem was. Are you guys hanging in there? Do one more, and then we'll do a break. All right, so what do you think we want to let u equal here? X squared, good. And so that derivative to x dx. Awesome. No, you want u to be something that's going to cycle down. So like when we did a derivative of x, we just get 1. Or like you want that to be something that's going to kind of go away. And you want the dv to be something that'll kind of flip back and forth, like how e to the x is itself, or how sine and cosine kind of flip back and forth, like in general. Some of them get weird and it doesn't really follow that, and I'm going to show you that, but in general, that's how you kind of want it to go. So we want dv to be sine of x dx. Antiderivative, that would be negative cosine of x. Perfect. All right, so it's going to be u times v. So that is going to be negative x squared cosine of x minus integral v du. Now, when you multiply these together, it is negative. So here's what I would do. This negative is going to cancel with this negative. Like you're subtracting something that's negative. So I would just go ahead and make that positive. 2x cosine of x dx, multiplying these together. Look at that for a second, think about it, because this one's gonna be a little bit different. Because we need to do this antiderivative. You have to do it again, all right? Yes, do you see how these are both multiplied together? That's why you want the u to be something that's gonna cycle down. We went from a squared to something to the first. Now, when we do this derivative, it's gonna go away and then we'll be good. Yeah, I'm not gonna do that to you. The most I would do is twice. But that's why you want u to be something that's gonna cycle. But that's so cool you asked that, because yes, in theory, like say this was an x to the 7th sine of x. You'd have a 7th and then you'd do it again and get it to the 6th, 5th, 4th, and then sine would keep switching back and forth, sine, cosine with some negatives in there. And eventually you'd get down to something that would work. I won't make you do it more than twice, all right? But u is gonna be 2x. So du is 2dx. dv is cosine of x dx. And so what is v? Sine of x, good. I need to zoom out because so much here. All right, so do you see this first part? That's not changing. So just bring that down to the next line. Plus, now let me just cover this up. Pretend that this was just the original problem. You would have u times v, so 2x sine of x, good, minus integral v du, which would just be 2 sine of x dx. So there's going to be like 3 terms in your answer instead of just 2. So there's a lot of copying. I'm just going to have to copy these down. All right, and now I need an antiderivative for 2 sine of x. -2. Now the reason we don't need a 1/2 is because it's not a 2x. Yeah. So those negatives are going to cancel. This will be plus 2 cosine of x plus c, and then this is your answer. And I know you won't, and I know you don't want to, but if you did the derivative of this, you would get x squared sine of x. All right, so I just said in general, you would want to let u equal something that's going to cycle down. So you would want to let u equal to x squared. Ln is kind of the exception for that, because what is the derivative of ln of x? So you want to let u equal the ln of x, because when you do that derivative, it becomes 1 over x, and that allows you to cancel an x when you multiply. So that's the reason you want to allow that to be that way. Also, if you do it the other way around, it simply will not work. And like I keep saying, if you get it and it doesn't work, just flip it around and then you'll be fine. So dv is going to be the x squared dx. And just remember, you have to do an antiderivative to get v. So what is v? X cubed. Good, perfect. So you're going to multiply u times v. So I would just put the 1/3 x cubed out front. So 1/3 x cubed ln of x minus integral v du. So you're going to have that 1/3 there. But do you see how you have an x cubed times a 1 over x? So like the reason that works out is one of the x's is going to cancel and you'll just have x squared. So if there's an ln in there, you want to let u equal the ln part. And then this first part's going to just be what it is. You just copy that. And then we just have to do an antiderivative here. So for the x squared, it would be 1/3 x cubed, but there's already a 1/3 there. So it'll be good, 1/9 x cubed plus c. I know I'm gonna have to get another piece of paper here in a second too. And this is always an interesting problem. This is kind of like a famous calculus one. Like everybody in Calc BC will do this problem. Because it's just ln of x, so it's almost like, what do you do there? But you need integration by parts to do this. So you would let u equal the ln of x, it's like the only thing there. So du would be 1 over x dx. dv would then just be dx. And I would say, like, maybe put a 1 in front of that. That helps sometimes. Like, it's not that there's nothing there. It's just like a 1 dx. Because what's your antiderivative of 1? Perfect. Good. It'll be x. Because sometimes people won't put a 1 there. It'll just be nothing. And then they'll put like 0 or something. So I recommend putting the 1 there. Oh, yeah, I guess you could think of it that way. Right, so you want to let u be the ln of x part, because that derivative is going to be 1 over x, and when we multiply these, it allows you to cancel an x out. That's like what it does. So this is going to be u times v, so it'll be x ln of x minus integral v du. So these cancel, and you just get 1 dx. And again, I would put the 1 there. I think that helps. I mean, that's like an opinion, though. You can agree or disagree. So this first part is going to stay. Again, antiderivative of 1 would just be x and then plus c. And the last thing is I want to do a couple that have boundaries on them so you can see how that turns out. And I'm kind of upset because I could fit one more problem here, but I want to do 2 of them. So let me grab another. I'm not going to change the process on you, but I'm just going to throw some boundaries in there so you can see how that turns out. Oh, and hey guys, remember, what are you finding when it's a definite integral? Like, what is your answer represent? Area under the curve. You're like, why does she keep bringing this up? Because people forget, and then we get to the end of the year and they're like, what's an integral? I'm like, oh. It's from 1 to e x cubed ln of x dx. Sorry, I know there's a glare there. So I know it's weird, but what would you want to let u equal for this one? Yeah, the ln part, because that derivative is 1 over x dx, and then that allows you to cancel out an x. Hi. And so then dv would be the x cubed dx part.